To India now, and authorities say they've now recovered 270 bodies from the site of the plane crash in Ahmedabad city on Thursday.
I'm not here today because I want to be here. I'm here today because I felt that I must come forward because I do not want to see another 787. I do not want to see 787 or 777 crash.
I think the board counts on me for transparency.
Really? Because you're under investigation for falsifying 787 inspection records. Boeing's under criminal investigation for the Alaska Airlines flight. You were investigated by DOJ for criminal conspiracy to defraud the FAA. This is all in your tenure. This doesn't sound like a lot of transparency to me.
It began quietly. A string of technical incidents, some shrugged off, others hidden in reports, were dismissed as isolated flaws. But in the shadows of Boeing's proudest engineering achievement, the 787 Dreamliner, a deeper, more systemic issue was forming. And then, after a shocking crash involving Air India's Boeing 787 just months ago, investigators made a discovery that changed everything. Inside one of the most advanced aircraft ever built, a technical violation was uncovered, one so severe, so fundamentally forbidden in aerospace manufacturing that it left even senior engineers speechless. And more disturbing than the defect itself was the conclusion. Boeing knew. They knew, and they concealed it. What follows is not just a story about software glitches or rivets gone wrong. This is a deeper autopsy of the Boeing 787 Dreamliner. One that reveals a sequence of technical, cultural, and managerial failures that may threaten not only the reputation of an aircraft, but the future of American aviation itself. I have analyzed Boeing's own data to conclude that the company is taking manufacturing shortcuts on the 787 program that may significantly reduce the airplane's safety and the life cycle.
I have analyzed Boeing's own data to conclude that the company is taking manufacturing shortcuts on the 787 program that may significantly reduce the airplane safety and the life cycle.
YouTube is not the biggest fan of content like this, but we believe people deserve to hear the truth. If you agree, hit that like button and subscribe. It helps us beat the algorithm and keep going. We really appreciate the support. Let us begin with the Ram air turbine system, often referred to as the RAT. This is the last resort device designed to deploy mid-air only if an aircraft loses all its electrical power. It spins through airflow and powers critical systems, so the aircraft can continue to operate during a catastrophic failure. But during a routine check at Phoenix Sky Harbor International Airport, the RAT deployed while the aircraft was stationary, not in motion, not in flight. Engineers, startled, immediately flagged the issue. A follow-up investigation revealed a serious software fault in the central power converter, an error that made the aircraft believe it had experienced a total power failure. This was not a random failure. Internal logs showed this fault had occurred in earlier testing phases. Boeing had the data, but instead of issuing a fleet-wide software update or even informing the airlines, the company buried the risk under layers of bureaucracy and silence. The decision: avoid public panic, protect the stock, shield the brand. The problem with that logic is simple. Aircraft do not fly on confidence. They fly on systems built to withstand unimaginable pressure, turbulence, and time. If the RAT misfires mid-flight, it could override the normal power routing, cut off autopilot, block navigational functions, and reduce pilot authority during a critical phase of flight. The result: an aircraft carrying more than 200 people could, with the flick of a code fault, drop into emergency mode with no real emergency. And at that altitude, seconds matter. But this incident was not an isolated crack. It was a fracture in the foundation. What investigators found next was worse. Behind the cockpit of every commercial aircraft lies a structure known as the forward pressure bulkhead. It is a sealed wall shaped like a dome, designed to hold cabin pressure at cruising altitude. Without it, air inside the aircraft would escape faster than anyone could react. Without it, There is no breathable environment, no structural integrity, no safety net. Investigators inspecting a 787 in Texas discovered misaligned drill holes in the bulkhead. Not just one or two, dozens. Some rivets were the wrong size. Others were corroded. Many did not reach deep enough into the load-bearing structure. These were not flaws in a prototype. These were discovered in aircraft that had been in commercial service carrying thousands of passengers. And the deeper investigators looked, the more defects they found across multiple aircraft manufactured at Boeing's South Carolina facility. This facility, already notorious for production line speed-ups and reduced quality checks, was now under direct federal scrutiny. The Federal Aviation Administration issued an emergency directive mandating the removal of all insulation around the forward pressure bulkhead in every Boeing 787 operating in the United States. That means no more flashlight checks, no more visual inspections from the outside. Engineers were now required to use endoscopic cameras and advanced imaging to identify tiny fractures, corrosion, and even foreign debris left behind during assembly. Boeing responded as expected. They issued a statement minimizing the risk, emphasizing that no known in-flight incidents had occurred due to this issue, but experts in Europe and Asia disagreed. They warned that just one gap, less than a centimetre wide, could cause a pressure breach at 11,000 nus. At that altitude, passengers would lose consciousness in less than 20 seconds, and then came the next blow. After a long-haul flight into Tokyo, engineers inspecting a mid-cavern floor of a Dreamliner noticed damp insulation. A deeper tear down revealed what no one wanted to find: water leakage into the electronics bay, also known as the E and E bay, the nerve center of the aircraft. This is where all electrical systems converge. It is the core hub for navigation, flight control, cabin pressure, communications, and power routing. The cause? Faulty seals in the aircraft's lavatories and water tanks. Leaks allowed fluid to seep under the floor, bypassing the insulation and dripping directly into sensitive circuitry. And it was not a new problem. Boeing engineers had raised this issue during initial production cycles, but the fix? Temporary sealant patches and more frequent inspections. The core design flaw was never resolved. The real threat here is not just the water itself, it is what the water carries. Assembly residue, metal shavings, conductive particles. These contaminants, when mixed with moisture and electrical current, can cause silent corrosion, smouldering circuits, and unpredictable failures mid-air, mid-flight. Now, if you are wondering why these issues keep coming back year after year, this is where it becomes clear. Returning to the investigation, one airline reported wet carpet in the cockpit. Another reported false avionics readings, yet Boeing continued to delay a fleet-wide redesign. Only after multiple complaints and an FAA escalation did they begin retrofitting aircraft with upgraded drainage systems. As this wave of discoveries continued, engineers turned their focus back to the bulkhead fault. The issue initially flagged in 2021, thought to be resolved, but it had returned. In March 2025, the Federal Aviation Administration ordered a new round of inspections, this time far deeper. Airlines were told to remove insulation and photograph the internal structure inch by inch. The findings: more microfractures, more incorrectly sized rivets, more corrosion. The issue, it seemed, was never truly solved. It had just been covered over, a temporary patch for a permanent problem. And that brought the investigation back to one key figure: whistleblower and former Boeing engineer Sam Salipur. Salipur had repeatedly warned about the South Carolina plant's shadow factory, a separate workshop used to retrofit and patch 787 fuselages that had failed initial quality checks. According to Salipur, these patched parts were not always properly refitted. Some were forcibly compressed to match the mold. Others were joined using non-standard techniques that violated the aircraft's intended load-bearing tolerance. Now, years later, those shortcuts are starting to show up as fatigue, corrosion, and unexpected failures in aircraft still flying. Adding to the complexity, not all Dreamliner components are built in-house. Some are outsourced, especially to international subcontractors. A recent investigation found that MPS, an Italian supplier, provided substandard metal parts used under the cabin floor to support structural loads. It is estimated that nearly 500 Boeing 787 aircraft contain these parts. How did this happen? Inspectors missed it. Boeing missed it, and in some cases, the flaws were discovered but passed through anyway because the delivery schedule had to be met, because the cost of delays was too high, because admitting a flaw would be bad for the bottom line. And it is not just old problems repeating. In 2023, a Boeing 787 flying from Sydney to Santiago dropped more than 120 meantos in less than 10 seconds. Passengers were injured. The autopilot had misread input from weather sensors and reacted as if the aircraft was in a stall. There were no warnings, no alerts, just a sudden plunge. It was traced back to a software glitch compounded by slight aircraft tilt and turbulence. And on a United Airlines domestic route, a pilot's seat jammed during descent, forcing the co-pilot to take over at the last second. The cause, a worn-out locking mechanism that had not been flagged for inspection because it was not on the list. These failures are not isolated. They are part of a wider pattern, a culture shift that began after Boeing's merger with McDonnell Douglas in the 1990s. From that moment, decision-making moved from engineers to executives. Safety was no longer the primary language, profit was. Reports surfaced, showing engineers being pressured to overlook issues. Inspections skipped. Component sign-offs rushed to meet delivery deadlines. Internal warnings ignored. Some whistleblowers were demoted or fired. Eventually, it was not just a problem of engineering, it became a problem of trust. By the end of 2024, the damage was clear. Boeing's chief executive officer resigned. The stock fell. Airline customers quietly shifted orders to Airbus. The Airbus A350, a direct competitor to the 787, has steadily gained favour thanks to a more stable safety record. And now, even the United States Federal Aviation Administration has stepped back from its previous close partnership. Independent inspections are increasing. European and Asian airlines are hiring third-party auditors to double-check Boeing's technical claims. Because at its core, the crisis is not just about rivets or bulkheads or water leaks. It is about credibility. The very thing that made Boeing one of the most trusted names in aviation is now eroding from the inside out. If nothing changes, the next Boeing 787 failure may not be as lucky as those that came before. If you found this video insightful, do not forget to hit that like button and subscribe to the channel. It helps us bring this information to more people, because what flies over our heads must never fly under the radar.